Monthly Space News, February 10th, 2024. Mostly talking about some probes on the Moon and Mars. Ingenuity, that was the last flight they had during this last month. This is the helicopter on Mars. It went up there with the Perseverance rover. It got dropped out of its belly, thing rolled away, and I've been using it for quite a while now, since April of 2021. They lost communication during a descent in January this year, and they got that restored, but apparently there was a rough landing. They use optical navigation, and what happens is they figure out where they are based on looking at the patterns, and normally the landscape looks more like this, lots and lots of little rocks and pebbles, relatively easy to do pattern matching to figure out where you are. But where they were was over some fairly featureless dunes. For all I know, this little mark right here might have been made by where the rotor of the helicopter actually hit the sand. I don't know that, but that seems pretty likely. Generally featureless. So the thing probably got lost. I wasn't quite sure where it was. It was able to take a picture, and you could see in the shadow, you can see that the rotor tip ended. It doesn't take much to break off to mean you can't fly because you get so much vibration. That meant that at least one of the rotors is broken. And they figured, well, if the thing spins so fast, chances are pretty good, they were all broken. Now, the rover still has power, still has communications. But the thing is, the communications only work back to the rover. So as the rover moves on, that's it. So they can talk to it for a little while. And as far as I know, they were still doing a little bit of that. But it will die. It'll have power for quite a while, but nobody will be able to talk to it. If a helicopter falls on Mars and no one's there to hear it, is it there? And just as a reminder, this was the Perseverance rover that's been up there for the same roughly 3 years that the helicopter's been there. The helicopter came out of that. That was kind of a mosaic picture. They put together a variety of different pictures, and then they kind of synthesized that. So it's all real images, but it's not one real image. This was the path that's been taken. The white dots there represent where the rover has gone. So it started off way over here on the bottom right, and this is the area basically where it landed. They picked a very flat area. They called that a landing field, that area there, where they practiced with the helicopter. They took it up for short flights and then little longer flights, flew it around until they really were confident that it would work. And then at that point, they started moving around. So each little white dot represents a stopping place for the rover, and each yellow dot represents a stopping point for the helicopter. Now, they did diverge for a while there. That rough area near the beginning of their path, the rover really couldn't have gone over that. So again, this was their first chance to start seeing, well, okay, we can probably take pictures and see and learn a lot more about Mars than we could just from the ground. And initially, the whole theory was, well, this is just, we're going to do 5 test flights just back here in this little initial area. That defines success. Once they'd done that, that was all they really expected. They just designed it for 5 flights. But it turned out it was much better than that. And they realized, okay, they can use it. They can use it as a scout. They can use it to gather more information. So it turned out to be pretty useful. But of course, it had to follow the track of the rover. As I said, in particular, the communications. It doesn't communicate back to Earth. It only communicates back to the rover. The rover communicates via satellite and then ultimately back to Earth. So they had to stay close. Now, at the end here, this is an area where, again, the rover could not have even gone. It's basically some sand dunes, and they'd be really afraid they'd just get stuck if they tried to drive into that. But they wanted to learn about that, so they're flying over it. But apparently, somewhere in there, this is when they finally died. And so this is the ultimate landing spot of the helicopter right there. And so what will happen is they'll continue. They're kind of moving to the left here as they move along. They're climbing gradually out of the crater that they're in. They're in this one big crater. They picked that on purpose because they can look at a lot of different sedimentary layers. That's basically a river delta that they're climbing out of there. Well, at least at one time there was a river. So they're climbing out of that. And they will be leaving it behind. So in retrospective, they took 72 flights. And as I said, the original design was just for 5. So that was pretty good. They flew 14 times farther than they had originally planned for design conditions, which is over 10 miles. About 2 hours of total flight time. The highest they flew was 79 feet, which is a lot more than about 10 or 20 they thought they could do originally. And they went a lot faster than they thought they could. They go about 22 miles an hour is the fastest they've gone. They stretched this. So as they were there, the longer and longer they were there, the more they pushed the envelope. They went up higher, they went faster. And it turns out it was actually a good thing that they can go higher, because what limits the range of the helicopter? One of them is it has to go slowly enough that it can recognize features on the ground so it knows where it is. Well, you go up high enough, you can go faster and not turn into a blur, so you can do a little better. The role ended up, instead of just being a test, it was really a scout. It can scout ahead. It can look at areas that can't be reached by the rover itself. If you were designing this thing, you have vastly different conditions to deal with than a helicopter on Earth. First of all, you only have about 1% of the atmosphere, which is roughly equivalent to 80,000 to 100,000 feet on Earth, pretty much the balloon territory. There's not much lift. So that says you're going to have much higher rotation of the helicopter blades, the rotors. And also, there's not much damping. Normally, air, you think of it as being pretty airy, but it does have some resistance to things vibrating. None of that on Mars. You do have a lot of radiation on Mars. That's high. That causes electronics failures. That's a big issue. Normally, the way they take care of that is they have radiation-hardened semiconductors. The problem is they're heavy and expensive. They had to just use commercial stuff. They have extreme temperatures, down to minus 130. A lot of dust. Thing is, they even did this for a fairly short period of time. This was added kind of at the last minute to this project. So they really only had a couple years to design and test it, which is pretty fast for most NASA kind of stuff. So it weighed about 4 pounds, 1.6 feet tall. They had very, very lightweight, high-strength blades for the rotors. The batteries are just pretty much standard cell phone batteries. They used a lot of off-the-shelf parts, including the cell phone CPU, Snapdragon 801, which was 2014 vintage, but that's much better than the radiation-hardened stuff, which is like 1990 vintage, and weighs a pound and costs $250,000. Yeah.
What brand of processor was it?
Qualcomm Snapdragon 801. 2014. That's when that processor first came out. Now they used it, for a few more years. But yeah, what they were going to do was detect failures. They assumed they were going to have failures, so they had some redundancy, like memory. They checked memories and that sort of thing. They disagreed. They did a quick reboot, even if they were flying. They could reboot in 0.2 of a second. Now, the other thing they did, they tried to use off-the-shelf hardware, including communications. They used Zigbee, which is actually a home automation kind of a thing. They use off-the-shelf chips for that. Line of sight only, which is a problem as they get to the areas where there's hills. So challenges, dust. They had a lot of that. Of course, you always worry about that on the solar cells. It also affected the mechanics. These blades, this is basically a dual rotor. They have to adjust the pitch to be able to control it. And the servos were finding a lot of resistance. It turned out there was dust. There's a thing called a swash plate, which is what actually rotates the blades to angle them. And they found they just had to cycle through that like 10 times, and that would knock off the dust. And the stuff on top of the solar cells shook off in vibration again. Winter. This thing was designed to fly in the spring, really, or spring or summer. It wasn't quite so cold. So they were just going to heat the thing during the night. But that didn't work in the winter. It's too long, too cold. They just basically had to restart it. So the thing essentially would die every night, and then they'd have to start back up in the morning. Now, the thing is, when they started from a cold reboot like that, it didn't know what time it was. So they couldn't coordinate easily, saying, okay, we're going to listen and coordinate with the rover.
That's really a cold reboot.
Yeah, literally a cold reboot. Yeah, so they had to just fly up, and then they could get their new marching orders. They had a dead sensor sensing incline, and they worked around that. They did an upgrade to automatically choose their landing sites. And this is a kind of a synthesized map where they said, okay, they showed the color here in red, don't land here, it's too rough. And the green area was a recommended, and they did this automatically. They didn't have that at first. Now it's coming. Well, one, a larger version for the sample return. They got all these samples lying on the ground there now. So if we do a sample return mission, they originally were going to have a rover go pick that stuff up in the event that Perseverance couldn't bring it back. So instead, they said, no, we'll just use a larger helicopter and use a helicopter. Then there's a Mars Science helicopter, which is a possibility, which is just bigger. And then there's Titan, Saturn's moon. It turns out a much better place to fly a helicopter. The atmosphere is much more dense, maybe 50% more dense than Earth. So you get a lot of lift very, very easily. So sample return, it looks a lot like the original, except it has wheels and easily be powered, and it has a little robot arm to pick up the samples. Science helicopter was a much bigger thing to do more serious work. And they're imagining flying down into craters and that sort of thing. Then there's Titan. Yeah, it looks massive here. Actually, I think it is the size of a small car. It is a pretty good sized thing. Actually, it's a much easier flying kind of a thing. Actually, people could fly there. You don't even need a pressure suit. It's like being maybe 16 feet underwater. You just need insulation because it's really cold. If you wore wings, you could probably fly on Titan. So they claim.
We are all witnessing an inflection point throughout the history of space exploration. It's like, okay, well, we're going to have a rover. We're going to do a rover to send north or south or east or west. And now it's going to, 20 years from now, they're going to say, it was so obvious to use a helicopter.
Yeah.
Why didn't we think of this sooner?
Yeah. Well, and there's only certain places you can do that. Mars, nobody would have thought it would work because the atmosphere is so thin. And yet you design it to be really, really fast spinning and it works. This one, yeah, actually, somebody did a calculation and it's like 1/40th the power it would take on Earth. It's just so much better. The gravity is much lower. It's actually lower than moon gravity, or it's comparable to moon gravity. But yeah, half the gravity of Mars, much, much thicker atmosphere. Piece of cake to fly this thing, except for the temperature. It's down to minus 260. Which is interesting. This is the only place in the solar system besides Earth where you have liquid lakes, you have rivers, it has snow. The only thing is those lakes are liquid methane. So it's a little different. People can actually live there. It's just you have to have a lot of insulation to keep warm, but it's not even so much of a problem like on Mars where you have to wear a pressure suit to keep from dying. You just have to keep warm. Okay, next up is lunar lander from Japan, SLIM. Now, we talked about this last time, and it had just gotten down, and they realized that the solar cells were not generating power. And that's where we left it last time. So now they've had a follow-up. They had a big press conference on January 25th where they went through all this. As a reminder, this is a Japanese space agency. It was launched back in September, a very, very long route to get to the moon. Finally got there. It landed on its nose, it turned out. But they did land where they wanted to. And it would have been a lot better if they hadn't been for the failure, which we'll talk about in a minute. And their emphasis on this optical navigation, just like we talked about with the Mars helicopter. Actually, everybody's doing that now. They're making a really big deal about it. They're just doing a good job of landing on the moon with it, but that is pretty much what everybody's doing. Basically knowing where you are by looking at pictures, because you have satellite pictures, so you have a rough idea. So solar cells weren't generating electricity. They didn't know why. So they only had about 3 hours to run before the batteries had run down. So they made good use of that time. It turned out that it was an orientation. The solar cells were simply not facing the sun. You can see them here. They're the little things on top of this. It's supposed to land on its side like this, and then the solar cells are on top, and everything would be fine. That's not what happened. But what was supposed to happen is it comes down, is hovering, step one here. And we actually covered this last time as well, so I'll try to zip through it. But they're coming down, and then right when they get about 6 feet, 2 meters from the ground, they actually turn off the engine, and they have a little side thruster that just flips it over on its side slightly. And so it lands, it kind of hits it first on the bottom, and then tips, and finally ends up like that. That's what's supposed to happen. That's what actually happened. It's on its nose, pretty close. Now, this is actually a pretty amazing picture. How did they get this? Well, when they turn off the engines at 6 feet, they have 2 little rovers. They pop them out, and they just drop to the ground. And one of them is a little sphere about the size of a baseball. That's what took this picture. But that one couldn't communicate back to Earth. It's sent over to the other little one that popped out, which I'll show you a picture of in a minute, which does communicate directly with Earth. It didn't even need to go back to the SLIM itself. They actually said that's also effectively a little ham radio station on the moon. Tiny little thing. That was the smallest radio transmitter to make it from the moon. Interesting picture. A couple of points about this. The shadows. The sun is coming this direction. The solar cells are over here on the right-hand side. So that's why they didn't get any power. And this, JAXA, the Japanese Space Agency, so they kind of recreated what it looked like. This is not a real picture, but it's synthesized based on all of the data they had on the position and everything. I guess they wanted to make sure it looked kind of artificial, having those little pyramids there. So basically what went wrong? Well, the landing was actually perfect until they got within 50 meters above the target. So that as they were going along, coming across from the left-hand side of this picture, they took pictures, they verified, they made corrections as they needed. Each time there's a little blue shot here on this picture, that means they were taking a picture and doing some pattern matching until they get toward the end. And then they finally are making the final approach, just trying to hover vertically, making final adjustments. So normally they're going right for the target. They have the target picked out, but they don't know the details of, well, what boulders are there going to be right there. So then they switch modes, essentially. They say, okay, Instead of prioritizing the target, now we prioritize flat area within that range that they're in. And so then they make little adjustments, and then the idea is they would land. So 50 meters was a major milestone in this landing. So what went wrong? Well, at that same 50 meters of altitude, suddenly they lost 45% of their total main engine thrust. Now there's two engines. You can see that on this diagram here. The small versions of the lander that you see on the far right-hand side of this diagram are simply rotated 90 degrees and maybe made a little smaller just to squeeze in the pictures. But you can see the two engines there. They lost it about 45%. And by looking at temperatures later, they figured out that they really lost most of the thrust on one of those two main engines. Now, that causes problems with unbalanced forces because you can imagine you've got a center of mass of this spacecraft and you've got two engines pushing against it. Well, if one of them almost completely goes away, you're suddenly just forcing all that force on one side of the center of mass and not the other. So that tends to want to tip it over. So the attitude adjusting thrusters can compensate for that to a large extent. However, control just simply gets more difficult, and they ended up getting some horizontal velocity as a result of that. So why did they lose thrust on one of those engines? Well, it turned out their downward-facing navigation cameras gave them the answer. They could see it. What happened was apparently most of the nozzle broke off on that engine, and as a result, it had much, much lower efficiency. And that caused them to only end up with 5% of the power remaining on that side. So the net result of all this was they were drifting horizontally way too fast. Slim just rolled over on its nose at the landing because of that extra horizontal velocity. And unfortunately, the way it landed, the morning sun was in the east, but the solar cells were facing west. Despite the rough landing, both Slim and its two rovers were working, even with that upside down kind of position. The only problem was that they didn't have power coming out of the solar cells, so they had to run on battery. They did that. They had spectroscopic analysis they could do with their camera, and they did some of that. They had to shut down after 3 hours, however, because the battery got down to about 12%, and they wanted to preserve the system so that they could start back up when the sunset brought the sun over to the west-hand side. So it turned out they did that. On January 29th, they restarted. This was getting close to sunset when the sun was now in the west instead of the east. And they continued doing their scanning and spectroscopic analysis. Finally, they did have to suspend activities on January 31st because that's when they hit sunset, lunar sunset. Now, will the craft wake back up after going through the lunar night? Probably not. It gets pretty cold, minus 208 degrees or so, but it is possible it could wake back up. But even if it does, they'll still have to wait until late afternoon, lunar afternoon, to restart because once again, it's still facing the wrong direction. Now, people have suggested that maybe they could fire thrusters and that sort of thing to move it around. They wouldn't have done that during their short 3 hour panic when they knew they didn't have much time before the battery ran out. But now that they've done some analysis, they might consider doing something like that. So I'm sure that's something they might be considering. As we mentioned, both of the mini-rovers were deployed successfully. The larger of the two is called LEV-1. It's actually a hopping robot. It doesn't have wheels, it just hops. Now, it actually communicated with Earth as well as with LEV-2, the smaller rover. Its communications package only weighs 90 grams, so it's pretty amazing that it could transmit all the way back to Earth for that. And that was received by radio amateurs, not just NASA people. It transmitted data that included photos, temperature, radiation, and incline. Those were sensors that it had. And in particular, it transmitted that picture that we saw already, the picture of Slim. That was taken by LEV-2, the other rover, and transmitted to Earth by LEV-1. It did execute its planned 6 hops until it ran down its battery, so they shut that one off as well. It's on standby. LEV-2 is a small spherical rover, shown here in the right-hand picture. It's about the size of a baseball. It's kind of transformer-like. It opens up and then it can roll along with the two hemispheres forming wheels. It did succeed. It networked with LEV-1 as it should, and it, of course, took that picture showing the upside-down Slim lander that was sent by LEV-1. Now, let's try a pop quiz. Weren't expecting that, were you? Can you guess the country and the rocket or spacecraft? Now, this was originally done before a live audience, our NSS meeting. However, we ran into some technical difficulties, so I'm re-recording this. You'll just have to imagine the excitement of the crowd as they tried to guess the answers to these questions about what these are pictures of. So let's start with this one. Anybody have any guesses on that? Not hearing any. Okay, let's take a look at a slightly expanded version of that picture. Now you can see the country's flag. If you know flags, you'd recognize that as the flag of Iran. It's also on the rocket itself near the top. This is a solid rocket. This is typically used for early efforts by most countries, partially because they usually want to do military applications, and solid rockets are much more useful for that. They can be launched at a moment's notice. There isn't a whole lot of infrastructure that's needed. You don't have to keep tanks around of propellants. You don't have to load them up laboriously over a day and that sort of thing. You just pretty much fire them and go. This particular rocket, yeah, it is a solid rocket. It was probably delivered by that truck that's in this picture. I don't actually know that. It could just be for site support. But this is a very bare bones kind of a site. It pretty much is just a big concrete pad. It does have a little bit of a deflector for deflecting the exhaust. Must be a bit of an angle. So this is launching an actual satellite into orbit. So the Iranians have succeeded in doing that. I don't really know how to pronounce it, but it is a Kuam 100 rocket. Okay, how about this one? This is clearly a much more substantial operation. Any guesses? It may help your guessing to know that this is the Khomeini launch site. This was also an Iranian rocket. It's called the Simorgh rocket. It was launched on January 27th. That's fairly amazing that after quite a few failures in the past, within the last 3 weeks, they've managed to put up 2 rockets. This particular rocket launched 3 test satellites. This is a liquid-fueled rocket, so it doesn't quite have that immediate military kind of application. However, of course, every country that starts off also wants to be sure to have reconnaissance satellites, and that's the kind of thing that they're testing out. Okay, what is this? Perhaps it would help to see this other view of the same spacecraft in use. This is the Cygnus cargo ship, which is by Northrop Grumman. It carries cargo to the International Space Station, and that's the Canadian robot arm grabbing it to bring it in. Unlike the Russian Progress cargo ships and the SpaceX Dragon cargo ship, this one does need to be grabbed by the robot arm. It doesn't have the automated docking the others have. The Boeing Starliner crewed capsule, when it arrives, it also will be able to just dock automatically. On the other hand, the Cygnus does have one thing that the other craft from SpaceX doesn't have, and that's that it has substantial engines that can be used to lift the ISS. And it is not as powerful as the ones on the Russian Progress cargo ships, but at least it does provide some way to lift ISS in the event that the Russians fail to do it. And this is that first picture, except it now shows the Cygnus nameplate, which I had obscured earlier. Okay, what is this? This is the first stage from an Electron rocket from Rocket Lab. This is their first full booster recovery. They've recovered an engine before, the same way, dropping it into the ocean, finding out that if they treat it properly to avoid the corrosion, that seems to work out pretty well. So here they're actually recovering an entire stage. They've reused the engine, but they haven't reused an entire booster yet. So this is a major step for them on the way to full reusability of their first stage. And finally, what is this? If nothing else, we had to include this picture just because it is so dramatic. Well, this is that very same Electron rocket, except this is being launched with that first stage in action. Well, that was our segue into our normal segment, where we ask, how many launches have there been since our last NSS meeting? Now, it's only been 3 weeks since the last meeting, so the number will be a little bit smaller than you're probably accustomed to. Here's a clue. All of those pictures I just showed included launches that were done during this last 3-week period. The one slight exception was that Northrop Grumman Cygnus craft. That did have a launch during this period, but that picture was from an earlier flight. Well, The answer was 13. There were 13 launches since the last meeting on January 20th. And of course, we've covered a few of these. There were the 2 launches by Iran. As usual, there were a bunch of launches of Starlink satellites, the internet service from SpaceX, and of course, that Electron rocket. That launch was from their New Zealand launch site. Even though they became an American company, still most of their commercial flights are out of their New Zealand site. Those particular satellites that they launched were monitoring of orbital objects, basically focusing on space junk. As usual, some Chinese satellites. One of those was, again, a sea launch. They've been doing a lot of sea launches lately. They just are trying to get a lot of rockets up into the air, and they're going to seaborne platforms to help do that. One Chinese commercial launch worth noting is the one for Geely. They put up 11 more satellites in their constellation. Geely is a Chinese automaker. They also own Volvo, but they have a large domestic market for their cars, and eventually they'll be exporting more and more. Anyway, they are putting up an entire constellation of satellites for several purposes, generally communications with those cars, and also to support autonomous driving in the future. So they're putting up satellites way ahead of any other car company. A major NASA launch was the PACE satellite. PACE is an acronym for Plankton, Aerosol, Cloud, and Ocean Ecosystem. Basically, they're monitoring the oceans in particular and their interactions with the atmosphere. So they're looking for things like aerosols, a feeling for how clouds really work, how they develop, and how they could be modeled to better predict climate change kinds of things. Clouds have a huge impact on the overall energy balance for the Earth because they reflect a lot of heat away from the Earth and conversely from below reflect a lot of heat back to the Earth. And there's quite a bit of uncertainty in how to really model that at a detailed level. So the hope is that the modeling will get better. This particular launch is to a near polar orbit. That means that it goes over the North and South poles. And the reason for that is that as the Earth rotates underneath it, it guarantees that every spot on Earth is eventually seen from a satellite in this orbit. Now, this was a particular polar orbit called a sun-synchronous orbit, which means that at a given time of day, the satellite always sees exactly the same scene. So it's easy to get repetitive pictures day after day of the same spot with the same lighting conditions. This was the first U.S. government polar launch from Florida since 1960, and there's a reason for that. If you're going to do a polar orbit, that means you pretty much want to go north or south. And from Florida, you can't really go north without going over a lot of population centers in the U.S. Then when you dropped your first stage at the end of its run, you'd end up dropping it on a population center. But even beyond the planned stage separation, there's always a danger of an abort during the launch, and that could really spread debris over a wide area that might be populated. So instead, you go south. However, that means you are passing over Cuba. The problem came in when back in 1960 there was a launch and there was a problem, and we ended up scattering debris all over Cuba. And there was a lot of protest about that. We did actually kill a cow as a result of that. There were all kinds of demonstrations saying the Yankees are killing our cows and this sort of thing. So finally, the U.S. government settled with Cuba and paid them $2 million. So ever since then, they've tried to avoid doing polar launches from Florida. They've typically been from Vandenberg Air Force Base over on the West Coast. Now, there have been quite a few polar launches that are commercial, done by SpaceX from Florida. The reason they can do that is that SpaceX came up with an automated flight termination system, an autonomous one. It can decide it's time to blow itself up to protect everybody without requiring interactions with the ground crew. And that was considered much safer, that there were no delays in terminating a flight. And as a result, they've gotten approval to do that on a regular basis. So finally, the government caught up with commercial practice. And finally, the Russians did put up another one of their military satellites. They really don't have the economy to support anywhere near the pace of SpaceX or the myriad Chinese organizations that are putting up rockets. But almost every time period, they do manage to put up a satellite. And that's it for this month. Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of the National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.